Welcome to Secret Squared. I'm Cassie Secret.
I'm Megan Secret.
And we're going to do a whole series on the many different exponent rules that there are. Today, we're going to talk about the product rule, which is one of the most common ones you're going to see. Now, let's dive in. Now, as we get into talking about exponent rules, it's really important to know what exponent rules actually are, like what that means. So exponent rules are certain like steps or procedures that allow us to simplify expressions that have exponents. So really our goal is when you're having several different expressions where maybe something is happening with them, we really want to make it simpler and nicer because it's going to make it easier to work with. So one important thing to note is just a little reminder, whenever you see things written with exponents, because at a certain point you might kind of forget what that actually means when you're working with it. What that really means is whatever the exponent is or that number, exponents tell you how many times you multiply that certain variable or that number that is the base of the exponent. Because like Megan was saying, a lot of times we see exponents and we just kind of forget what they actually mean. In this video and in our whole series on what exponent rules are, we're really going to keep reminding you like what it actually means. Like not just, oh, there's an exponent, but what is that exponent actually telling you? Because it's actually going to be the key to be able to figure out what to do with these rules and to make sense of them. It also helps you remember the rules a lot better. So now that we're kind of reminding you that exponents are how many times you multiply either that variable or that number, here's some like quick examples. For the first one, we're going to have 7 times x to the third. So reminder that x, since it has the exponent of 3, all that means is we really have 3 x's being multiplied together. This exponent just makes it easier way to write it rather than having to write it fully written out like how Cassie's going to write it out. Now, something I really want to make sure is clear, that 3 is next to the x. It only belongs with the x. That 3 does not go with the 7. For the 3 to go with the 7, you would actually need to have a set of parentheses. So just be careful. There is only one of those 7s because that 7 has an invisible exponent of 1. And then like Megan was saying, x to the power of 3 means we have 1, 2, 3 x's. So we can write it all the way out. However, it does get kind of annoying, and that's why we came up with exponents, because we wanted a way to simplify it. So one other example that might look a little bit different is something like 12 squared x y to the fourth. Now, it's first you want to make sure you know what exponents we have. So first thing is we have an exponent of 2. Unlike the one above, this exponent goes with the 12, so it goes with a number instead of a variable. We have that term, we have the x, that does not have an exponent, so we're going to assume it has a 1. And that y to the fourth, we have that 1. That means we end up having 4 y's. So if we were to write it out fully, this means we have a 12 times a 12. We have just 1x being multiplied, and then we have 4 y's being multiplied together. All right, so again, that exponent is really just telling you how many times that you are multiplying whatever it is that has that exponent. Now, just to show one more example that has some parentheses in it that you could see, if we have something, let's say it's negative 2a, and all of that is to the power of 3. Now, in this case, we actually do have parentheses, which means that everything in the parentheses has that exponent of 3. So this entire piece, that entire negative 2a, we are going to be multiplying that once, twice, 3 times. So it looks a lot more complicated when you have those parentheses, but it just means whatever's inside it is being multiplied, or it shows up however many times that, however big that exponent is, in this case 3. Now, when we talk about exponent rules, we are going to talk about a lot of different ones, but for today, we're just going to focus on what we call product rule. Now, we're going to use product rule when we are multiplying terms. Now, the reason that it's multiplication for that one is product, if you guys don't know, is the word for what you get after multiplying things together. So for our first example, we're going to see 3x squared times 4x. So we're going to not use the exponent rule, but we're going to try to simplify this as much as we can. We're not going to show you exactly what the product rule is yet, but we'll see how understanding what 3x squared actually means can help us simplify it. Now, because our goal is, yes, we are going to show you the rule, and I'm sure that if you're watching this, your teacher's probably already shown you it, but what can be really difficult is understanding why it works, and so that's really what we're going to break down right now. So if we actually break down 3x squared, that gives us 3, and then x squared means x times x. So we have x times the x. If we break down the 4x, we actually don't have to break it down at all. It's just a number, and There's one number, one variable. Yep, and again, what we're using here is that exponent of 2 tells you how many of the x's you're going to have. And just a little note, we are adding some of the multiplication dots. Now, if in any spot you're not seeing the multiplication dot, like between the 4 and the x and the 3 and the x, that's just because we didn't include it, but if it's not there, we assume it is there. And then from here, we can start with just the numbers in the front. We have 3 times the 4, that gives you 12. You don't do anything fancy for that. Yep, so don't overthink those numbers. And then for the other chunks, we have just the variables. Total, we have 3 x's all together being multiplied. Even though technically it's this x times the 4 times the x, it doesn't matter what order you multiply things in. So we have total 3 different x's all along that string of numbers. So we have really times x times x times x. And if you look at it again, we have 12. And then we can actually rewrite the far right chunk as x to the cube, or x to the third, or x cubed, because there's 3 of them. So actually our final answer is 12x cubed. And so again, that's why we like to use the exponents, because we would prefer for our end answer to not have to write 3 x's out. But by writing them out like during the process, it's going to help you see what we're doing. Now, let me go ahead and move that off to the side as we do our next example. Our next example, we're just going to make things a little bit more difficult, but we're still going to show you ultimately the same exact type of step. Yeah, it's still the same idea of breaking it down, seeing how many certain variables that you have. Now, for this one, we're going to have -4x, don't be scared, we're going to put another letter, do y squared, times 5x to the power of 3, or x cubed, and y to the power of 4. And then when you break that down, it's going to look a little bit messier than the last problem, but only because there's more letters. Otherwise, it's going to be the exact same thing. So we have that -4. There's just one x, so times x. Y squared, we're going to have 2 y's, so y times y. So that was that whole first term. For the second term, we still have that 5, but we have 3 x's, so we'll do x times x times x. And we have 4 y's, so we'll do y times y times y times y. It means the same thing, it's just now fully written out. And again, by fully writing it out, I think that it is the best way to really make sense of the exponent rule besides just memorizing it. And then from here, you'll keep going like we did for the last one. So again, don't overthink the numbers in front. We have that -4 and that 5. Those are just numbers that are being multiplied. So multiply those, you get -20. And from there, we want to do the same idea, but now we want to look at our letters. What is really important is the letter X and the letter Y are not the same letter. So the way that we did up here, where we just put all the X's together, you can only do that when you have the same letter. So it's not just putting the variables together, it's putting a certain letter all together. So we can look, we have 1x here, 4 x's here. So we have really x to the 4th. Yep, so we're just counting how many x's we're multiplying. And then we can look at all the y's. We have 2 y's right here, 4 y's right here. Total, we have 6 of them. So we're now saying, oops, there we go. So we have that -20, x to the 4th, and a y to the 6th, because there ended up being 6 y's all multiplied together. Yep, and then just one little side note. We here are going to write it with the number in front, and then for the letters, we go in alphabetical order. If you had this in a different order, if you had put the y in front and then the x, you are by no means wrong. It's just we're used to normally seeing the variables show up in alphabetical orders. Yes. That's the most common thing that tends to show up. Yep, so that right here is going to be our final finished answer. Okay, so now that we actually did some examples, we want to get into how that actually is going to give us what is called our product rule. Now, so this is the example from the last page, or the last example on that page. We have here's the question, and here's the final answer. So pretty much we didn't have any of those in-between steps of us really working through it. Where the -20 comes from, that comes from those coefficients, the -4 and the 5. Where it gets a little different is where we get the exponents for the x and the y. So for the x, it's x to the 4th. Where that 4 really comes from is we have an exponent of 1 for the x there, and we have an exponent of 3 for the x right there. The reason why it ends up being 1 plus 3 gives us this 4 down here is we have 1x right here. X to the 3rd means we have 3 x's being multiplied together here. Total, there are 4 x's being multiplied. So instead of like actually having them and writing them all out and counting how many there are, a shortcut is to look at the exponents for that letter and add them together. Now we can do the same thing for the y. So right here, there's 2 y's being multiplied here. Here's 4 more y's being multiplied. 2y's plus another 4y's gives us total there's 6y's being multiplied. And this is what can give us the product rule. So it's saying if we have two things being multiplied together where they have the same base, and that a and the b, it just is a stand-in for any number. So maybe a is 2 or b is 5 or any number, but what really matters, like Meg said, is that those x's on the bottom are the same. You have to have the same base. Yeah, so this keeps it generic, and then really what you do is now you're gonna have just one of that base, or 1x. You're going to add the exponents together. So now we have the a plus the b. Yep, and it makes sense that we're going and we're now just gonna have one of the x's there, because our goal in doing these exponent rules is to try and simplify everything as much as we can. So this is a much more condensed form of what we had to start. So for our first example, we're going to use exponent rules. We're specifically use the product rule to simplify this. But instead of like the last page where we wrote every single bit out, we're actually just going to use the, not the shortcut, but the faster product rule. Now, please note, if you like writing it out, if that makes more sense for you, we encourage you, please go for it. Do that a lot. It can be really helpful. It just can get kind of annoying if you have like an x to the 9th or something, but even then you could still, when in doubt, write it out. So looking at this, we're going to start with the very first term, or that that coefficient. So we have -6 times the 2. That gives us a -12. Because those coefficients in front, those are just numbers being multiplied. Multiply them like normal. Don't overthink it. And then we can do our next variable. You have to go one letter at a time. I'm going to start with a, but oh, there's no a's on the other side. So, and for the product rule, we need to look at the things that have matching bases. That a, that's the a, but there's no other a that shows up. So that means that that a is not getting multiplied with any other a's, so you're just going to leave it. If you're thinking about it like on the other page, where when we were writing out all the letters, here we have 3 a's, and this next set is not going to give us any more a's, so it still just stays a to the power of 3. So we've dealt with the coefficients, we dealt with the a's, now we can switch and look at the b's. We have 1b here, b to the 4th right here. Again, there's no exponent really to 1, so we have that 1 plus the 4. Total, there are 5 b's being multiplied. So now we have b to the 5th. So make sure it actually looks like a 5. There we go. So b to the 5th. And for the last thing, we have a c. And that c is actually the only c that shows up throughout the whole question. So we are going to bring that straight down. There's no other c for it to multiply with. Yep. So for this one, this is going to be our final, finished, and done answer. So for our last example, we're going to do what we just did with the last one and use the product rule. So we're going to be mainly looking at the exponents and adding them together. So in this case, instead of 2 separate chunks, we actually have 3. But even though there's more things to work with, it's actually going to be the exact same steps. So we can first start with the coefficients, or the numbers in the very front. What makes this look a little bit different is we do have a 2 squared. You technically can do the exponent rules of the product rule with numbers as bases, but it's a little bit easier instead of looking at it as 2 squared. And yeah, instead of 2 squared, we can go ahead and make 2 squared into what 2 times 2 is, which is 4. Like Megan was saying, you could use the product rule when you're multiplying numbers. However, they would all have to be the same base, and that's not really the case for all 3 of these numbers. So it's going to make your life a lot easier to just go ahead and write them out just with normal numbers. Yeah, because we're used to working with numbers without the exponent, so it's easier to get rid of that exponent and simplify it a little bit. So I just went ahead and I erased that to the power of 2, and I just rewrote it as 4. And from there, we can go ahead and take all of those coefficients in front and multiply them. So I have 4 times 4, which is going to give us 16, times that -3 will give us -48. So that's going to be the new coefficient for our answer. After we've dealt with the number in the front, now we're going to deal with all of the variables. So I'm just going to go alphabetical order. We have our a's, and I'm going to highlight any other a that shows up. We have one more here, but we don't have any in that last chunk. Yep, and that middle a, I don't see an exponent, so just put an exponent of 1. So total, we have 8 a's being multiplied here. We have one more a being multiplied there, so there are 9 a's, or 8 plus 1 gives you the 9. So we have 8 to the 9th, and reminder, that really just means that exponent 9, there are 9 a's total being multiplied. Now, you would have gotten the exact same thing if you took the a to the 8 and you wrote out all of the a's. However, you might not want to. Especially by the time it gets to 8 a's, it might be a little much. But again, if you like that, go ahead and do it, okay? It's going to get you the exact same answer. So now looking at our next letter, let's look at b. I have a b squared. I have a b to the sixth, and I have another b in the last at the very end that should just have an exponent of 1 because I don't see it. And so I have two b's that are being multiplied, six more b's, and another b. So you really can add those exponents, 2 plus 6 plus that 1. That's going to end up getting you b to the power of 9. And then for our very, very last letter, we pretty much are just picking up whatever we've missed so far. There is a C over here. There is no other C anywhere else. So that C, we don't have to combine it or multiply with anything else. It's just going to drop right on down. And for this one, I'm not going to put the exponent of 1. You totally can. But if we don't see the exponent of 1, we're going to assume that it is an exponent of 1. Yep. And then again, just a reminder, we like to write our letters in alphabetical order. You are not wrong if you don't. However, this is the most common way that you're going to see it written. And that there gives us our final finished done answer. Thanks for watching. If you enjoyed this video, please like and subscribe. If you have any other topics you want us to cover in later videos, let us know in the comments below. We'll see you next time.